Okay, so for today's lesson, we're going to talk about points, lines, and planes. This particular lesson is pretty visual. I'm just going to be filling in some blanks on your note sheet, but if you don't see it, if you don't see what we're trying to talk about, then you definitely want to come in and see me, because I do have planes that I can actually show you, and lines and crates and stuff like that to help you visualize what it is that you need to see. So this part should probably be a review for at least the beginning. A plane is an infinite set of points. Don't know how that happens. Try that again. An infinite set of points generating a flat surface with no thickness. A plane extends forever in all directions. A plane is also defined as a surface such that a straight line joining any 2 points in it lies entirely in that surface. Okay, so basically what's happening here is if I pick a line, I can put a plane, a line can lie in any plane, I guess is what I'm trying to say. All right, so coplanar points. Coplanar points are a set of points that all lie in the same plane. Any 3 points must be coplanar. So I can pick 3 points anywhere that I want and find a plane that will contain all 3 of those points. Coplanar lines are lines that lie in the same plane. Those lines could be parallel, those lines could be intersecting, they could be perpendicular, which is intersecting. But for the most part, as long as I've got 2 lines, I can pretty much find them a plane for them to be on, with the exception of this next one, which is skew lines. And skew lines are lines that do not lie in the same plane. What's happening here is this particular line is on the plane, but this particular line goes through the plane at that point. So the dotted line is supposed to represent how the line is going through, like you're stabbing a pencil through a paper or something. When speaking about lines and planes, there are 3 possibilities. So a line is either going to be in the plane, and that's what this is, a line that's in the plane. Okay, so a plane contains that line. It could also be where a line intersects the plane at exactly 1 point. That's this particular example, where through that point P, a line goes through it. So you go through that paper. And it's also possible when we're talking about lines and planes that a line doesn't intersect the plane at all. And if that's the case, it's going to be parallel to that plane. And that's that 3rd example. So lines are either contained in planes, lines go through planes at exactly 1 point, or lines never touch the plane because they're parallel to it. Okay. So a plane in that is determined by 4 different ways. One way for sure that you can get a plane is if you have 3 points that are non-collinear. So if there's ever 3 non-collinear points, you can always get a plane around them. If you have a line and a point that's not on the line, you can also always get a plane around that. So this would be a line and a point not on the line. A 3rd way to get a plane to exist is to have 2 lines that intersect. And then a 4th way for a plane to exist is to have 2 lines that are parallel. So if you ever have a situation where you have 3 non-collinear points, a point and that's not on a line, 2 intersecting lines or 2 parallel lines, you can always find a plane that can contain all of those different things. However, if the 2 lines are skew, there is never going to be a plane that's a K. There's never going to be a plane that's going to contain those 2 lines. And hopefully you can sort of see in this diagram, almost like in our classroom, where you've got a line maybe going across the floor from wall to wall, and a line on the ceiling that's going from the opposite wall to the opposite wall. they will never intersect. They're considered to be skew, and there's no way a plane is going to be able to contain both of those lines. Planes that don't intersect are called parallel planes. So that's kind of like the floor and the ceiling. Those are planes that will never intersect, and they're parallel to one another. And then last but not least, if two distinct planes intersect, then the intersection of those planes happens to be just a line. Okay, so that's it. Again, a lot of these things are very visual, so you might want to come in and check out the crate and the cardboard pieces that we have and the little lines that we have if you're not really sure how to figure something out. All right, so good luck on the homework. And shout out to Sean.